Mars captures the imagination more than any other planet. No other known planet has as Earth-like an environment, yet they are still very different. Mars is enough like Earth that evolutionists have expected to find life there. However, none has yet been found. Probes sent to Mars have sent back gigabytes of data. This wealth of data has revealed a relationship between three major Martian geological features. They are among the largest of their type in the solar system. These geological features include the Hellas Impact Basin, the Tharsis volcanoes, and Valles Marineris. The relationship between these features is unlikely to be a result of chance, suggesting a cause and effect relationship between them. All this implies a global Martian geological catastrophe comparable in scale to that of the Genesis flood. This Martian global catastrophe was not a global flood, but it was a global catastrophe. This is supported by additional evidence from the twin rovers Spirit and Opportunity. Opportunity seems to have landed in an area that was catastrophically flooded, despite uniformitarian claims that it was a long-standing sea. Even on Mars, when uniformitarian geologists see different layers of rock, they think geological ages. JPL is already claiming that the rock layers found by Opportunity are billions of years old before even one radioisotope has been measured. It is claimed that these layers represent different epochs of Martian history, despite the evidence that they are only local occurrences. They do this based on their preconceptions resulting from how they think the solar system formed. However, they have missed considerable evidence for catastrophe. Now let's take a look at these Martian geological oddities. Hellas is the largest impact basin on Mars. It is also one of the largest known impact basins in the solar system. Hellas is basically a crater about 2,100 kilometers in diameter, which is about 1,300 miles. It is also 9 kilometers deep, that is 5.6 miles. For comparison, Hellas is about half the size of the continental United States and as deep as Mount Everest is high. Hellas' center is located at about 70 degrees east and 40 degrees south. The bottom of Hellas is the only place on Mars with a high enough atmospheric pressure for liquid water to stay on the surface. The energy of the Hellas impact has been estimated at about 5.33 times 10 to the 26 joules. This is a blast of 127 billion megatons, which is equivalent to 8.5 trillion atomic bombs the size of the one dropped on Hiroshima. The Hellas impact dwarfs any known impact site on Earth. The famous Tunguska explosion is estimated at about 500 kilotons. The Chicxulub impact, thought by evolutionists to have killed the dinosaurs, is estimated at about 100 million megatons, with a crater that is at most 180 kilometers across. Earth's largest known impact, called the vertiform dome, is about 300 kilometers in diameter. Now, Earth impact sites do provide insight into the results of large impacts. The Chicxulub impact would have put so much dust into the Earth's atmosphere that it is accredited by most paleontologists with killing off the dinosaurs. The Hellas impact would clearly have thrown up thousands of times as much dust into the Martian atmosphere. If the impacting body came from the asteroid belt, the impact velocity would have been about 7 kilometers per second. This means that the impactor's mass was 2.2 times 10 to the 19th kilograms. This mass is similar to the asteroid Juno, with a diameter of about 206 kilometers. Opposite Hellas on the Martian surface are the Tharsis volcanoes. These are also the largest volcanoes in the solar system. Directly opposite the center of Hellas, at about 110 degrees west and 40 degrees north, is the western side of Abapatura's caldera. Abapatura is the largest Martian volcano by surface area. The Tharsis volcanoes include Olympus Mons, the tallest mountain in the solar system. It is 22 kilometers, that is 13.6 miles high, and 600 kilometers, that is 360 miles across. Coming off of the Tharsis Plateau is Valles Marineris, the largest known valley in the solar system. Yet another Martian geographic oddity is the fact that most Martian craters form a hemispherical pattern on the surface. The center of the hemispherical pattern is about 30 degrees west of the center of Hellas, placing Hellas near the center of this hemisphere. The twin rovers Spirit and Opportunity landed on Mars in January of 2004. Since then, they have sent back a wealth of data. Both rovers have found that Martian soil is largely volcanic ash. Many of the rocks they have examined are composed of the volcanic rock basalt. When Opportunity landed in the Meridiani Planum region of Mars, the scene that it showed was strange even for Mars. Not only was the soil darker than any other landing site, but the ground was covered with innumerable hematite nodules. They are evidence of water and volcanic activity. Hematite is also present in the soil, giving it its dark color. The outcropping of rocks in the crater Opportunity landed in were made of uneven layers. This type of layering shows that they were laid down by moving water. This helps provide evidence for a global catastrophe. The rocks were also strangely eroded. Some of the rocks had hematite nodules embedded within them. Some had the hematite nodules out on sticks of rock. These patterns have persisted throughout the area that Opportunity has explored. The deeper craters show deeper rocks in layers of different rocks. Chemical analysis shows that much of the rock in Meridian Panum contains sulfates, a byproduct of the reaction of sulfuric acid in water. The Meridian Panum region of Mars shows evidence of large amounts of water flowing into it in a catastrophic manner, including an inflow channel at one end and a splatter zone at the other end. This inflow channel has ridges that are consistent with a flow channel, and the splatter zone shows evidence of flowing over underlying terrain in a chaotic fashion, similar to the termination of a mud flow. The evidence suggests the Meridian Planet suffered catastrophic flooding sometime in the past. The craters studied by Opportunity are blasted through layers of rock, showing that the flooding happened before these impacts. However, other craters in the area show evidence of forming before the flooding by the sedimentary patterns of the craters. These craters have sedimentary deposits up against the crater walls, and in the opposite direction of the flow of water. The Hellas impact sent a shock wave around and through the planet. This shock wave would have focused on the exact opposite side of the planet from the impact, which is the location of Alba Pettura. The focusing of the shock wave would have caused cracks in the crust, and given a weak crust area with a pool of magma below it, such a crack would have resulted in a sudden burst of volcanic activity at this point. The cracks would have continued along the area of weakened crust, forming other volcanoes. This is supported by the fact that 4 of the Tharsis volcanoes form nearly a straight line. They are Serenius Talus, Acreus Mons, Pavonis Mons, Arissa Mons. Mercury shows that this type of effect can occur. Mercury's largest impact basin is the Caloris Basin. It has a diameter of 1,300 kilometers, which is 800 miles. It is about 2/3 the size of Hellas. On the opposite side of Mercury, from the Caloris Basin, is a lineacted hilly area about 100 kilometers across, which is 62 miles. The crust here was broken into jumbled blocks by the Caloris impact. All this would have resulted in massive amounts of volcanic activity, thus filling the Martian atmosphere with volcanic ash, including large amounts of sulfur. With such high levels of volcanic activity, the ash would have increased the Martian atmospheric pressure to the point where liquid water could exist on the surface. Much of the volcanic material would have formed the volcanic mounts. In Tharsis, the concentration of volcanoes would have caused a pileup of volcanic material, forming much, if not all, of the Tharsis Plateau. Most of the remaining volcanic ash would have covered the planet, becoming a major component of the Martian soil. The volcanoes would have ejected chunks of lava. These chunks of lava would have cooled and solidified in flight, and some of these rocks would have landed at some distance from the volcanoes, cracking on impact. At first glance, the hemispherical pattern of craters seems hard to explain by the resurfacing of the lightly cratered north. Furthermore, Hellas being near the center of this hemispherical pattern complicates the problem. However, the relationship between Hellas and Tharsis provides a solution. A closer look at the southern dip in the crater pattern shows that it is entirely part of Tharsis, suggesting that the plateau likely covers part of the southern highlands, making them look more spherical. This conclusion is supported by crustal thickness measurements made by Mars Global Observer. The fact that Hellas is on the opposite side of the planet from Tharsis naturally places it near the center of the hemispherical pattern. Also, since the northern lowlands have a lower elevation than the highlands, more volcanic and ejected impact material settled in the north. This is because it is easier for dust to be blown from a higher to a lower elevation. This process would also be aided by the fact that most, if not all, of the volcanism occurred on the thinner lower land crust. The results would be a nearly complete resurfacing of the northern lowlands. Valles Marineris is a large rift valley that is about 4,000 kilometers long, which is about 2,500 miles. This is about the same as the width of the continental United States. Its identity as a rift valley is supported by the sudden decrease in the thickness of Mars's crust under the valley. This suggests that the crust has been stretched in that area. The cause of this stretching could simply have been seismic activity associated with the Tharsis volcanoes. However, the proximity of the Agari impact basin offers another possibility. That is that the shock from this impact may have rotated the crust under the southern part of Tharsis, stretching the crust at Valles Marineris and compressing it to the southwest. The flooding at Merendi Planum seems to have originated at about 12 degrees south and 31 degrees east, based on the patterns of deposited material in the surrounding terrain. An eruption of underground water seems to be the most likely source. Underground water would be under pressure, causing it to be ejected at high velocity and resulting in the erosion of considerable amounts of material to become the sedimentary rocks found by opportunity. However, an impacting body cannot be eliminated as a possible source since no eruption point has been found. Some of the flood water went in different directions, but most of it would have rushed downhill into the Merendi Planum region. This water would have been loaded with material, some of which was deposited over the area explored by opportunity. It has been shown that sedimentation in moving water can form multiple layers simultaneously. As a result, a sudden flow of rushing water could have easily have laid down all of the rock layers observed in the Merendi Planum region. The leading edge of the flowing water would have formed a splat zone, as observed in the northern part of the Merendi Planum region. Once flooded, the water would likely have remained as long as the volcanic ash covered the planet. As the volcanic ash settled, the sulfur would have reacted with the water, forming sulfuric acid. The environment of this temporary lake would have been more like that of a car battery than an ocean. The presence of concentrated sulfuric acid would have aided the formation of the hematite spheres Opportunity found all over the area. The craters studied by Opportunity resulted from impacts that occurred while the area was flooded, and the concentrated sulfuric acid eroded the rocks, producing the erosion patterns that have been seen, including the hematite spheres on sticks of rock. The rover Spirit landed on Mars January 3, 2004. The area showed no evidence of flooding. The soil was found to be volcanic in origin. The rocks were also found to be volcanic in origin. However, the volcanic activity that formed the soil and rocks does not seem to be local. Many of the rocks in the area were cracked and broken. Some of the rocks in the area give evidence of being formed by water. This shows that there was some water in the area. However, no signs of massive flooding are present. The Mars Science Laboratory Curiosity is more than a Mars rover. It is a complete mobile lab. Powered by a radioisotope generator, it does not need sunlight to operate. Curiosity landed on Mars in Gale Crater on August 6, 2012. The Mars rover Curiosity has found crossbedding at an area inside Gale Crater called Glenelg. Not only does this show that water once flowed here, but the direction of that flow as well. It shows that the water that laid down this crossbedding flowed from Mount Sharp, which is predicted by the catastrophic model of the past water at this site. This provides evidence for eruptions of underground water and answering the one main question about the source of water for the flooding of Merendi Plenum. That is, it shows that the region was most likely flooded from an underground water source. While it is being reported as evidence of past habitability on Mars, Curiosity's first drilled rock sample analysis actually showed evidence of past sulfuric acid, like the Merendi Plenum region of Mars, where the rover Opportunity landed. This sample shows significant levels of both sulfur dioxide and hydrogen sulfide, which are often a residue of sulfuric acid. According to catastrophic Martian geology, the liquid water that was once present at Gale Crater would have been a concentrated sulfuric acid. Erosion patterns in the rocks had already indicated an acidic environment, but the discovery of sulfuric dioxide and hydrogen sulfide clinches it. While the results produced by Curiosity show that Gale Crater was indeed flooded with water, it also shows the water was too acidic for life. This means that a claim that Gale Crater was once a potential habitat are more evolutionist wishful thinking than science. Most of the geologic record on Earth was deposited during the Genesis flood. The size distribution of craters shows that the Earth and Mars were hit by the same population of objects. As a result, the events described here likely occurred at about the same time as the Genesis flood. Data suggests the following scenario. About the time of the Genesis flood on Earth, Mars gets hit by an asteroid about 110 kilometers, that is 130 miles across, along with many smaller objects across the southern highlands. This impact triggered massive amounts of volcanic activity on the opposite side of Mars. Heat from this volcanic activity warms Mars while filling the atmosphere with large amounts of volcanic dust and carbon dioxide gas. This increased the atmospheric pressure and temperature to the point where liquid water could exist on the Martian surface. A combination of heat, increased geological activity, and smaller impacts caused several underground water sources to erupt to the surface, flooding nearby areas, but not all of Mars. Over time, the volcanic activity ceased and the warming trend ended. With large amounts of dust in the atmosphere, Mars began to cool drastically, causing both water and eventually carbon dioxide to freeze. The settling of volcanic dust and freezing carbon dioxide reduced the atmospheric pressure, sending the planet into its current state. Evidence on Mars shows that the planet we see today to be the result of a massive global catastrophe resulting from a large impact accompanied by many smaller ones. This impact triggered a large amount of volcanic activity resulting in liquid water flowing on the surface while it lasted. Subsequent global cooling then froze the planet, and volcanic dust settled all over Mars, forming its present-day soil. This process would have been aided by accelerated nuclear decay, but does not necessarily require it. In conclusion, Mars and Martian geology are consistent with a young Earth creation model, nor is it the potential haven for life evolutionists make it out to be. This is supported by additional evidence from the twin rovers Spirit and Opportunity. Opportunity seems to have landed in an area that was catastrophically flooded, despite uniformitarian claims that it was a long-standing sea. Even on Mars, when uniformitarian geologists see different layers of rock, they think geological ages. JPL is already claiming that the rock layers found by Opportunity are billions of years old before even one radioisotope has been measured. It is claimed that these layers represent different epochs of Martian history. Deep, that is 5.6 miles. For comparison, Hellas is about half the size of the continental United States and as deep as Mount Everest is high. Hellas' center is located at about 70 degrees east and 40 degrees south. The bottom of Hellas is the only place on Mars with a high enough atmospheric pressure for liquid water to stay on the surface. The energy of the Hellas impact has been estimated at about 5.33 times 10 to the 26 joules. This is a blast of 127 billion megatons, despite the evidence that they are only local occurrences. They do this based on their preconceptions resulting from how they think the solar system formed. However, they have missed considerable evidence for catastrophe. Now let's take a look at these Martian geological oddities. Hellas is the largest impact basin on Mars. It is also one of the largest known impact basins in the solar system. Hellas is basically a crater about 2,100 kilometers in diameter, which is about 1,300 miles. It is also 9 kilometers Mars captures the imagination more than any other planet. No other known planet has as Earth-like an environment, yet they are still very different. Mars is enough like Earth that evolutionists have expected to find life there. However, none has yet been found. Probes sent to Mars have sent back gigabytes of data. This wealth of data has revealed a relationship between three major Martian geological features. They are among the largest of their type in the solar system. These geological features include the Hellas Impact Basin, the Tharsis volcanoes, and Valles Marineris. The relationship between these features is unlikely to be a result of chance, suggesting a cause and effect relationship between them. All this implies a global Martian geological catastrophe comparable in scale to that of the Genesis flood. This Martian global catastrophe was not a global flood, but it was a global catastrophe.